Alright, so in the last video we introduced proportions and we threw around ratios and fractions. But I just want to step back and briefly talk about when we use ratios, when we use fractions, and percents. Right? These three categories. And I guess we can throw decimals in there as well. So briefly, what I'll say across the board is that there are two types of relationships, and I'm going to elaborate on them. We have a part-to-part relationship, and a part-to-whole relationship. Alright, these two types of relationships can really help us understand what we're going to use here. Now, typically, percents, of course, can go either way, even though it might not always seem to make sense in context. We could apply percents both ways, but typically percents are part-to-whole relationships. For example, 20%. What does that mean? Well, it's 20 apart out of 100, the total. Fractions are typically introduced as part-to-whole as well. For example, if someone says you have 1/2, what that means is you have 1 out of 2. And we'll put some context to that. Ratios, however, typically are part-to-part, although not always. But an example is, you could say, well, in this room, there's one guy, right, for every two computers. So there's one guy for every 2 computers. They're separate groups, so they're part-to-part. And decimals, though, they can go both ways. So I think I'll start off is by covering ratios and why and what part-to-part means. So again, a ratio typically is used in a part-to-part context. So we have ratios. They're typically part-to-part. And this is not going to affect so much your calculation process, but it's definitely going to affect the context of how you're setting up your problems and the way that you read the news and the media about when they're using ratios. This is just, you always want to be aware, is our ratio part-to-part? Or sometimes ratios, I mean, they can always be used this way, but sometimes it doesn't always happen. They could be used as a part-to-whole relationship. And let me explain the difference. So let's say we have a classroom, right? Here's the teacher teaching, and we've got a couple of students in the room. Here are their very nice chairs, right? And they're sitting. And we've got a boy over here, a boy over here, and then we've got 1, 2, 3 girls over here. There's many ways to describe the amount of girls and boys in this room, but as a part-to-part relationship, you could say, well, there's 2 girls, 2 boys, right, there are 2 boys, for every 3 girls. Or you can say 2 boys, 2, 3 girls. And often you might just see 2 to 3, or like this, 2 to 3. You could write these as fractions, there's no reason that you can't. But this is we're trying to highlight ratios here. And this is saying, well, we have 2 girls, 2 boys in the room, right? And 3 girls. Those are 2 parts of the same group. We have the girl part here, these 3 girls right here, and these 2 boys over here. The girls aren't out of the boys, right? It's not a part-to-whole relationship. We'll get to that next. We're just comparing 2 different groups, and that's a part-to-part. And we could switch this. It could be 3 to 2, right? Or 3 to 2. This part-to-part relationship compares 2 separate groups, or 2 separate things. It's not a part-to-whole relationship. What would a part-to-whole relationship be? Well, I would say, you could say, well, there are 2 boys, right, for every 5 kids in the class. That's a part-to-whole, because the boys are a part of the whole class, the 5 people in it. Or you can say, well, there's 3 girls for every 5 people in the class. And here, when you're given a part-to-part, you should add the components to find the total number of people, right? But when you're given a part-to-whole, the total is given right here. And the only way to know if you have a part-to-part or part-to-whole relationship is to actually know the context of the problem. And that'll help you think about the data you're being given through a ratio. So anyway, so a part to whole. Now, typically what you would see is a fraction. There are 3 girls out of the 5 people. Or there are 2 boys out of the 5 people. Right? You might see either of those. But we could write them over here, and this is not typically how we write things, but we could say there are 2 boys for every 3 girls. Mathematically, this is equivalent to this ratio, and we can work with them in similar ways. It's just not usually what we would say for a fraction, right? If we think about going back to basics here, if we have a fraction, you're shown what a half is, they cut the pie in half and say that's a half, right? Over here, you've got 1/2, and here you have another half, which is saying out of the entire pizza pie, which has 2 pieces, you have 1 piece, half of it. That's a part-to-whole relationship. A part-to-part relationship is a totally different concept and can often confuse people. If I saw a 1 to 2 as a part to part, that would say perhaps you have one cookie for every 2, 1 chocolate chip cookie for every 2 sugar cookies. So here we have 3 components. A sugar cookie right here, and another sugar cookie right there, which are tasty. And here's your chocolate chip cookie. Here, you have 1 chocolate chip cookie for the 3 cookies in total, and to get that I added up the 2 parts. Right? That equals the whole. Now, what would this be that could be a part-to-part fraction, although this does not mean the same thing as this fraction right here. You would need 4 cookies in order to represent this as a part-to-whole. Right? To say you have half of the group maybe of chocolate chip cookies if you had 2 of them, but we don't have that right here. And in fact, if I wrote this as a part-to-whole relationship, I would say there's 1 chocolate chip cookie for every 3 cookies, which equals 1/3. So as a part-to-whole relationship, you could say 1/3 of these cookies are chocolate chip. As a part-to-part, you would say we have 1 chocolate chip cookie for every 2 sugar cookies. And that's a hard word for me to say. I'll say sugar cookies. Alright, anyway, I hope this helped. And percents, of course, sorry, I'll just cover that really quick, is almost always a part-to-whole. Here we have 50%, where 100% is the whole pizza, and you have 50% of the pizza pie right here. A percent is typically, of course, part-to-whole, and that's the whole design of percent, to think about 100% as your whole. And the decimals can go across part-to-whole, part-to-part, and can be applied in any way that we see fit. Thanks a lot.